Alright, so up to this point we've created a models folder. We've created a patient file which basically models a patient for us. It says this is what a patient in its most simplistic sense looks like. First name, last name, patient ID, email address, and phone number. We created a data repository, and you can kind of just wrap your head around that idea. The data repository is the conduit that allows our program to talk to the database. Some people would design their websites, their applications where that database information actually lives inside of their event handlers. And it works. You can write a full application and do it that way, and it will work perfectly fine. The problem is that when you start to add another form, multiple forms, and you've now spread your database code all over your application, you have a lot more management issues that you need to deal with. And those management issues come into play when you have to manage the connection string. Or if you need to pull the same data from the same table in two different forms. And you realize all of a sudden that, oh, that wasn't a very good select statement. I needed to add a field, or I added a field to my database, so I now need to modify my select statement in some way to reflect that field. So you have to do a lot of find and replace work to find where does that select statement live that references that table. So building one class that acts as your repository, as your conduit, encapsulates that, puts it in one spot, and then you can always create an instance of that class and then call the method you need to get the data you need out. It also eliminates the need for repetitive work of unpacking data from the database and putting it into objects. So remember, C# is an object-oriented language, so your objective is to deal with objects, to deal with classes. You don't want to deal with strings of data or rows of data. You want to deal with objects. In the real world, we deal with objects, so you want to try to model that and get as close to that as possible. All right, so we have our data repository, and then we have our MDF, our actual SQL database file. So inside of here we have get patients, created a list of all patients. Currently it's empty. We created our database objects, our connection object, our command object, and our reader. Our using statement, since it's an unmanaged resource, allows us to kind of protect that unmanaged resource. We say create this unmanaged resource, and while we're inside of this using block, run these steps. Once we exit the block, destroy and clean up that unmanaged resource. So we said, here's our connection string. We took all of the static components, local DB /v11.0, integrated security is true, and then the final piece is the attached DB file name, because we're using local DB, so we're attaching a file. And then we just append to that connection string environment.current directory plus appdata /cp week8db.mdf, which is our database. It lives right there. So from there we said connection object, give us a command object. We then said command object, here is your command text. This is the query I want you to run. And then we walk into the try catch. And this is do work. Open the connection. Hello. We call command.executeReader. That tells the command object that we want you to execute this query, and the result object we want returned is a reader, is a data reader. We're going to interface with this with using the data reader. When we take that reader and we store it in a variable. I said there was two other ways to execute. You had execute scalar and execute non-query, and there is execute XML reader, but that's not that commonly used. At least I've never had a lot of experience with it. Execute scalar. Start there. Execute scalar means go run a query, and instead of putting a star in my select statement, I'm putting one field, and I'm expecting one row. So the scalar value is one row with one field. You're like, why the hell would I need one row with one field? when you do an insert, you can run an insert statement, and then right after it, inside of the same transaction, you can say select identity. What select identity does is it will return to you the primary key that was given to the row that you just inserted into the database. So if you go in and you do an insert statement into a database, you want to know what that primary key of that object is, or that row is, so that you can then assign it back to your object. So by saying select or execute scalar, running the insert and the select in the same command will actually return you one value, which will be that primary key. All right? Execute non-query. When would you want to execute a non-query? That's not a rhetorical question. So you run a select statement, you want it to return you data. You want to get rows of data back. Execute scalar, you just want that primary key value back. When would you want to execute a query and not get anything back?
Update.
And?
Delete.
So you're deleting. Obviously, you don't need any data back. An update is a one-way transaction. Here's some data, update the database. Last name change, phone number change, uploading a new picture, replacing a photo, something like that. So you may be curious to say, well, what happens if I run execute reader and I'm doing an update? You can do it. It'll work fine. You'll get a reader back and it'll be empty. So you've now wasted resources on having it create a reader for something that has nothing inside of it. You could run execute reader on a scalar, and that will work perfectly fine. You'll get a reader back for one value, so you'll have to read through one row to grab one field. So it's kind of about efficiency when you think of it from those perspectives. Under the hood, these command objects are doing a lot of work. They're actually reading those streams of data, those strings of data that are coming across. They're actually bytes worth of data, but it's reading all of that and it's converting it into something that's usable and understandable by you, instead of you having to muddle through bytes and bytes of data that you're having to parse and delineate and figure out what it is. So minimizing the amount of work it's actually going to do is in your favor to get a more efficient application. All right, so we have our reader. The first thing we need to do is create an instance of the object. The object is the object that we're going to load the data into. So our goal here is to pull patients out of our database. So I'm going to say patient P equals new patient. Actually, I'll just call it patient P. The next step is to read from our data reader. So reader.read. And I put that inside of a while loop because when you call read returns true or false. It actually does two things. It looks at the number of rows in the reader currently and it says, is there one more? Is there another one? If there is, it says true and it actually steps to that next record. So when the reader first is given to you, it's not sitting on record 1, it's sitting up in the header at record 0, because there's the potential that there are no records in your return. So it starts at 0, and you say reader.read, and it says, yes, I have a row. And it moves to the first position. It's ready for you. Now, we can initialize patient. And then we can say p.firstname equals reader dot field. I don't have my link extensions. Let's do it this way instead. Reader, open bracket. So we have indexers off of our reader. We can pass a number, an int, or we can pass a string, a name. Passing a number, you're passing the field number in its position when it comes back from your select statement. So what you're saying is, give me field 0, give me field 1, field 2, 3, and so on. When you do a select star, it's going to return you the fields in the order that they are in the database. So as long as your database fields don't move, you can hit them by their ordinal positions. If your fields move, or your select statement has fields explicitly defined, you can still use those ordinal positions, but you need to guarantee that those field names never get moved around in that select statement. It is faster to use the positions, the numbers, because then the computer doesn't have to think. It doesn't have to do string comparisons. It doesn't have to go out and find those fields. So it's much faster to use the numbers, which means in most cases that you need to explicitly define the field names in your select statement. Now, we're talking about efficiency and process and things working fast. Well, sometimes it's faster for us to do the work, to let the computer do the heavy lifting and not have to deal with managing all that. So for us, we can put in a string, which is the field name. So I'll say first name. Now, if you look at the signature of this call, you'll notice that it returns an object. So we have to cast these appropriately in order to put them inside of the properties. So if I mouse over first name is a string. Reader first name is an object. Now this is from experience. My gut would always say, oh, .toString, right? Boom, perfect, works. This works great until you end up with a field that is null or undefined. You then get an exception thrown saying, sorry, can't take something that has a null reference and call toString on it. Strings can be null, but if the object is null, you can't call toString on it. So a better approach that allows you to receive null strings is to do the cast this way. Or if it's a reference value, you can say cast as string. Oh, I'm sorry, what am I doing? That's SQL. As string. But that only works for your reference value. So your by value values, integers, booleans, basically your numbers and your bools always are by value, so you have to use the other cast. So we'll just do it the other way. So now that's one approach to making this work. You can also do, and if you notice, I'm setting my properties. I'm saying this object P property equals the value out of the database. You can also do reader dot, and there's a function called fields. Oh, there's field. Maybe it's fields. I'm waiting for my IntelliSense to kick in. I guess it's not going to. And it lives underneath, it's an extension method. And I guess it's not loaded. is loaded.
I think it's data dot data set.
What is it?
Data dot data set.
Well, for the data set it is, but what I'm looking for is
That's
the...
what you just looked up, isn't it?
No, it's the data set extensions.
Oh, yeah.
But I know it's in like a weird... Okay. Let's see, I want data reader field extension. Get string, blah blah blah. Maybe I'm confusing it with get value extension. Not so is it going to tell me where it lives? Nope. Okay. I'll have to find it. But there is an extension method that allows you to basically do the cast for you automatically. So it takes some of the work out of having to do these casts explicitly. But if you can't find it, then it's just more work to go look it up, right? Alright, so we populate our instance of our patient, and then we're going to say all patients, which is our collection that we declared above, dot add p. So we now have that patient object that we created from that row of data from the database in a collection, in our list. So while there's rows to read, this will loop through one row at a time, populating the object, and result being all of our patients. Okay? So that's the basic mechanics. I mean, it's not really much more complicated than that. It's simply query a row out of the database, store it in a field, one field at a time. Once you have all of those fields loaded into an object, add it to a collection, go on to the next row. Get that data out of that database as fast as you can, put it into something in memory, carry it around, and use it in your application. So let's jump back to our form. Toolbox. And we'll just use a rich text box for right now. Doc. So inside of our load, page load, we're going to get the repo, fetch the patients, load patient data into the text box. So I'll do a for each loop. So for each patient, P in patients, I'll do rich text box 1 dot text plus equals, and then I'll use the string dot format. So that'll be first name tab, last name tab, email address tab, phone number, and then I'll do, that'll be patient ID. So it'll be p dot first name, p dot last name, p dot email, p dot phone, p dot patient ID. So we do F5. No. Yep. New line, F5 again, and there we go. So we've now gone and we've sucked that data out of the database, put it in a series of objects, and then taken those objects, looped through them, and output the data into the text box. Right? There's no hard coding this data. It's all in the database. If I want to make changes to it, I actually am going back to the database itself, making the changes here. Close, F5, and those changes come through when I run. You're like, okay, well, it still kind of feels the same because you had to stop and start. It's not really fancy. I can give you fancy. Let's see. I dock to the top. And I'll add a button to the bottom, which I will dock to the bottom. btn refresh. Refresh. And what I'm going to do here is I'm actually going to pull that data out of the form load, or the code, and I'm going to add two things here. I'm going to rich text box clear, remove data.
Don't you want that in its own method so you can call it from form load also?
I'm going to call the button click from form load.
Oh, okay.
Because the event handler is a function. So I can say btn refresh underscore click, and I'll just pass it null and null. So when the form load occurs, it's going to actually call this method btn refresh. It's a method. It's wired to an event, so when the event happens, the method's called. But the method can also be called on its own. So form load is going to call btn refresh click, which will run this code. So form loads, there's my peeps. I will go into my database. Wish I had a bigger monitor. Ooh, that's not helping. And we'll say, I don't know who. Sarah Silverman. Okay. The other end of the pipe. Oh, that's fun. Okay. Okay, I get it. Cancel. I lost the connection. Okay. That was not a good choice. Chaplin. Huh?
Because it was a comedian.
This is still a comedian. So now I click refresh. It's going to make a liar out of me. Alright, so what's happening? Patience 3. Okay.
You're not reading the database again.
Hmm?
Are you reading the database again?
I am.
Oh, read both IQ pages.
But I think what's happening, I think the reason why I ended up with this unusual error over here so I had this open before I ran the app, right? And then this became unresponsive. So let me close that. I'm going to leave that open, start again. So it read. And then I went in here and said and I got this. The reason I got this error says a transport level error occurred when sending a request to the server. What is happening is I open up this editor, I'm connected to that local DB instance via Visual Studio. My app launches, it then establishes its own connection to local DB, detaching the database file and attaching it underneath my app. So my app now has ownership of that local DB instance because it's not a true SQL server, it's an in-process isolated instance. Visual Studio is then trying to come back and say, okay, I'm still needing to use that. I need to commit or add this new record into the database. And it's saying, sorry, somebody else is using that file now. So it's basically like a file lock, but it's happening within SQL. So that's why when this wasn't working and I hit OK and went out and I went back in and I was able to add the row, I'm actually kicking my application out. That's why when we hit refresh, we're not getting new data. We're still reading the old data files. So it's this song and dance with local DB. All right, so how do we emulate something that really works? Let's go into the repository. Let's add another method. Okay. Now, and I think I've said this before, and I'll say it again. I'm one for not replicating code. I like to reduce or deduplicate my code as much as possible. I don't want to have the same code in more than one place. So what I always like to do is look at my code and say, okay, where can I pull things out and put them in their own space? How can I isolate them, make them modular? So first thing I'm going to do is I'm going to take these two DB objects, I'm going to cut them, I'm actually going to take my page and I'm going to split it. So above will be get patient, and down below, if I go all the way to the bottom here, I'm going to make another function, private DB connection, or I'm sorry, DB SQL command is what I want.
You split the page.
Magic. See this little guy up here in the upper right hand corner? The little up down arrow with the split? Click and hold, drag him down and it'll split for you. So you're splitting within the screen that same file. So we'll do get command. I'll put those two objects in there. So let's keep cruising down through here. Now here's where the using statement starts to not, it falls apart a little bit. So what we need to do is get command is going to create the connection and a command object for us. So we're going to take, I'm going to skip over the using statement for a minute. I'm going to grab connection string initializer and command initializer up to this point. So these 3 lines, I'm going to cut them. Now I'm going to put them in get command. Get command is going to take string command text. I then can take this part of the command initializer and say command text equals command text. Return command. Alright? So then I'm going to put up here SQL command cmd equals get command select all from TBL patient. I still need to open the connection, but I'm going to now say cmd.connection.open. Because down in get command, the connection object is giving me a command object. Part of the process of it giving me a command object is it's assigning itself as the connection. Smart, right? There's a connection property off of the command object. So I can say command.connection, which gives me the connection object. .open, so I'm saying open connection. I can then say cmd execute reader. Because I moved the command object up into the using statement, the command object dispose method will clean up the command and the connection that it's using. So I now have a reusable routine to get me a command object to make commands. Side note, inside the using statement you can also do your declaration. So instead of having to declare CMD outside of the using statement, I just go ahead and say SQL command CMD equals and initialize it inside the using. Alright, so that's get patient. So now add patient.
You didn't instantiate your connection on the
It's instantiated right here before it gets returned back.
No, the seal and you declare it, but you didn't instantiate it.
You talking about in here?
In get command,
Yeah.
no, further down in the actual method of get command.
In get command?
Yeah, see how con has a red squiggly line?
Ah, gotcha. Thank you. So con equals new SQL connection. Thank you. So since I took that from the using statement, I did need to initialize con. Now, we could, well, we can't. You may say, well, let's use the using statement in here. If we were to wrap this inside of a using statement, that using block has to terminate at the return. So that means that this function could be called, but when return happens, it'll return the object. It'll return it by reference. But it still has to follow the requirements of the using statement. So it's then going to attempt to clean up the connection object, which we don't want it to do because then we've lost our connection object. So by using the using statement and then calling get command, we're still facilitating the cleanup without worrying about it getting destroyed at the end of the method. All right. So, do you guys know what parameterized queries are? Queries with the little @ symbol variables in them. Did you see them or experience them in your SQL classes or in your co-ops or in your whatevers? Okay. I will save those for next week then instead of spending more time. All right, so quick and dirty. String, insert statement, equals, insert into, TBL, patient, values, let's see, so it'll be first name, last name, email address, phone number. Oh, it's not going to like that. First name, last name, email address, phone number. The values will be first name, last name, email address, and phone number. Alright, so using SQL command, cmd equals get command, insert statement, cmd dot command text. Actually, let's just do this. Empty string equals string.format, insert statement, comma, p.first name, p.last name, p.email address, p.phone number. So we'll do try block, cmd connection.open, cmd.execute execute scalar, which also means that I then need a select identity there. Object obj return equals execute scalar. We then can say p.patientID equals as int obj return. Assigning pk to patient ID. And that would actually probably work. Yeah, it's by reference, it should be fine. Alright, so that gives us the functionality to add another patient. So I guess I'm going to have to totally give up on the whole docking thing with this guy. No dock. Ooh, that was fun. Make the form a little bit bigger, make this a lot smaller. Toolbox, and for the sake of time, this is first name, this is last name, this is email, and this is phone, and this is our add button. So our add button will then do a data repository. We'll have a patient, new patient, equals new patient. And we'll say first name equals txt firstname.text, last name equals txt lastname.text. Email equals txt email.text, and phone equals txt phone.text. And then we'll say repo.add patient p. And then once, oh, it's not p, sorry, new patient. And then once we're done, we'll call button click. Refresh. All things work as they should. We have 3. We click add. Oh, it's going to blow up. Boo! Invalid cast exception. My guess is the exception was there. So if you view details, stack trace, whoop, line 91. So line 91 of the data repository.
That's where it's from.
Yeah. Oh, that's this. Thank you. Does it say the one before that then? 64? That's the call. That's not it. Alright, let's stop and run again. Yep, that was where it threw. So if we add it to our quick watch, okay, so that's funny. So when you call execute scalar, it returns you an object. So you have to capture an object. Patient ID is an integer. So the obvious thing is we're getting a number, 5. It's a whole number. In our database, we declared it as an int. So we should be getting a whole number back. For whatever reason, execute scalar is returning us an object, but packed inside of that object is not an integer, it's a decimal. So by taking the obj return and bringing it into either the quick watch or the regular watch, you can just right click on the variable, add to quick watch, pops this window. The quick watch will actually show you the name, the value, and the type. The type is object, but it's doing what's called boxing. It's boxing that a real data type as an object. It's kind of camouflaging it, if you want to think of it that way. What the real data type is a decimal. You cannot explicitly convert decimals to ints because you run the risk of losing significant figures. Decimals can be very small decimal values. You convert it to an integer, it comes out as probably 0 or 1 or something thereof. That's why we're getting the cast exception. So how do we get it to be an int? We can say int dot, we could do a parse, so we'd have to take the object, convert it to a string, and then do a parse. Or we can say convert to int32. And the convert class has a series of these static methods that allow you to convert to and fro. So if we have 5 again, and we'll then do sj me@u.edu 1 2 3 4 5. And we do an add, we should be successful. And then there's our new record out of the database.
Why did it skip 4?
The reason it skipped 4 is that when I was typing in that stuff and then it failed because I didn't have something aligned correctly, it actually assigned it an identity value and then whacked the row. So if you do bad commits in a database, depending on how the commit fails, it will actually assign that bad commit an identity value and then you lose it. So that's why we went from 3 to 5. So we can put anything in here now. We can do Sarah Silverman.
Oh, he's using her.
Oh, if we took the break out, it would look more impressive. So there you go. I'm going to exit the app, go back to our patients table, say show data. Apparently that's still open. From the bad commit. Say show data again. Oh, lie. Hang on. Oh, well, I just whacked it. All right, can you explain why?
No. I have to save it or something.
No. Remember we talked before about the whole compile and always copy? All right, so 2 things are happening. This database, all right, let me go the other way because it'll make more sense. There's database files inside the bin directory, right? These are the database files that we're running against when we actually launch the application. When we're inside Visual Studio, this is not the same database. This is the one that lives 3 folders up inside of this app data folder. So 2 things are happening. One, which is the more significant, and that's why we lost everything, is that I closed the app, I relaunched. When I relaunched, it went ahead and copied the database with the 3 rows back over top of the one that had 6. So we lost our data because of that. B, even if I had gotten the commit to work because we were in debug mode, it still wouldn't have been reflected inside of the running app because they're running on two different copies of the same database. So, to make this actually work and be functional without whacking rows, we have to go up. Wait. So that takes us to bin. Okay. So if we run now, I got it wrong. Win debug up bin. Database with the same name exists.
Just taking your dots literally.
Yeah, I know. Okay. There it is. That's what I was trying to show you from the get-go.
So you write to the same directory.
Yes, they're writing to the exact same database file. Yes.
Oh, it was mismatched.
Yes. Because it was doing the copy into the bin directory. So the running application was running off that version, where Visual Studio was still running off of the development version, the one that we were actually building the database from. So now they're both in sync, running off the same instance. So any change that we make here is reflected, and we can see it in Visual Studios and vice versa, which is what you would expect. All right. So that was a good adventure. And the win in the fact that we only had to make the connection string change in one place. All right. I know the last part was kind of fast. I know we're at the end of the class, but any questions around this? All right. So this will obviously be posted up on Blackboard. You can review it. I'll have the lecture up as well so that you can watch it again and review what we did. So just remember these concepts of this data repository. This is what we're wanting to establish so that we can have this centralized place for communicating with the database. We create these methods off the repository that facilitate selections, inserts, updates, and deletes. Inside of here, we have the connection object, the command object, and the data reader that are tools we use to communicate with the database. So those all kind of wrapped together is what enables us to do a database connection. Those are the basic mechanics. We did a little bit of the ORM piece, mapping the data together from the database into our properties of our objects. Next week, I'm going to introduce the entity framework into this. The entity framework is Microsoft's solution to database mapping. We don't have to write select statements. We don't have to build connection. Well, we have to build a connection string, but we don't have to use the connection, the command, and all of this stuff. Instead, we say, here's some classes, here's a database context, connect to this database, and it actually looks at our classes and tries to map them automatically for us. You basically say, go add this object to the database. It figures out how to write the insert statement. So it's very black box, very Voodoo-esque, but it works, and it works pretty well. And at least if you understand these mechanics, you know what it's trying to do for you, because it's basically doing this for you in a dynamic way. Okay.
General applications, it can be used instead of the MS Management Studio, the Database Management Studio, or
The entity framework.
no, I mean the whole matrix that you can do, like remotely without having actually SQL Server. Right, everyone's there to understand the application of the whole.
What we've just done.
Versus, like running SQL Server Management Studio.
Well, so SQL Server Management Studio, you would use it to actually manage the database. Where what we're doing here is we're actually having our application,
Bringing the processing later, whatever we
right,
like,
or
like
providing,
data,
right,
data
or
mining or something like
right,
that.
or providing the user with an interface that's not them writing an insert statement. I mean, a normal user working at a bank, working at an insurance company, let's say, is not going to be writing insert statements when they need to add a new record for a new customer. They're going to be interfacing with a Windows Form application that has fields and drop downs and things like that. So that's the objective. Is you use C#, you write a nice clean interface for the end user, and then you take care of the work of doing the SQL. But if you're debugging or crunching data or whatever that may be, that's where you as the developer, as the database manager, if you want to use that term, you're using SQL Management Studio to really get under the hood and look at what's going on. So if you wanted to, technically, you could write your own SQL Management Studio using these tools. So you have the capacity to do that. You wouldn't want to, but you could. So, okay, that is all I have for this week.